Hi friends, 5.8, last video of the unit, which means we're coming up on a test. Yes, I said that nasty T word, test. Okay, so this is our last video here. My yellow lab Copper is here with me today. Copper, say hi. Oh yes, you're a good girl. Okay, now go lay down. Alright, so we're going to take a look here at graphing. There's a couple things you want to keep in mind when you're graphing inequalities. One, there's a whole area of solutions. So one of the big things that you got to remember when you're graphing inequalities is that you have to shade where your solutions are. So if you would like to pause this for a minute and go grab some nice colored pencils, feel free to do that. Otherwise, let's get started. The other thing that you want to remember when you're graphing inequalities is that you need to decide whether your line is going to be dotted or solid. So that's one of the things that I like to decide right from the beginning, so that when I go to graph it, I've already decided that and I don't accidentally make a mistake and make it solid when it's supposed to be dotted and whatnot. So if you take a look at the first one, we have y is greater than or equal to x squared minus 1. So let's think about what form this happens to be in. It could be standard, could be vertex, but I'm going to get a little bit of information from this graph. So I know that my y-intercept here is -1, so that would be 0, -1. And if I look at it as vertex form, then my vertex would happen to be, oh, look at that, 0, -1. Because I could write this as y equals x minus 0 squared minus 1. So that's how I'm getting the vertex to be 0, -1. So my y-intercept also happens to be my vertex. So I'm going to go ahead and plot that point. Now remember, once you have your vertex and your a value is 1 or -1, your quadratic has a nice little pattern. Remember, over 1, up 1. Over 2, up 4. Then we go up 9. So 5, 6, 7, 8, 9. Go ahead and graph my mirror image points over here, because we know that in a quadratic, your points are symmetrical across that axis of symmetry. Now, this here, greater than or equal to, means I'm going to have a solid line when I graph it. So I'm going to go ahead and, if my pen cooperates with me here, which it's not cooperating. Oh yeah, look at that, it's making it dotted. Alright, give me 1 second to fix this. Okay, let's try this again here. One of these days, the pen's just going to die and there'll be no more videos. Just kidding, I'll buy a new pen. Okay. So we have y is greater than or equal to x squared minus 1. Now, if it's greater than or equal to, you shade from the parabola up. Okay, so what that means is that I am going to shade in this intersection here. So if it shades greater than or equal to, and it's opening up, you shade inside. Now, one of the ways that you can tell or decide which way you're going to shade is you can pick a point either above your parabola where it's opening up or outside of the parabola. So that would be, let me get my little hand here. That would be, if it was outside the parabola, it would be anywhere over in this area here. Okay? It's inside my parabola, it's opening up, it's anywhere in here. So if I test a point, 0, 0 is always a good one to test. Okay, I would put in 0 for y and 0 for x. So is 0 greater than or equal to -1? Yep, sure is. It's true. And so the point 0, 0, which happens to be right in the middle there, that's a solution. So I want to make sure that that is in my solution area. Now, if you only have one parabola that you're graphing and shading for, you don't have to label with an S. That comes more when you're graphing more than one. Alright, so let's take a look at the second one here. I'm going to go ahead and say that this is in standard form, so my y-intercept in this case would be 0, because notice I don't have a c value here. So 0, 0 happens to be my y-intercept. Okay, and I'm going to go ahead and find my vertex. Let's do a little practice with the axis of symmetry here. So negative b over 2a, so it's going to give me 4 over 2, so 4 divided by 2, that's 2. Okay, now, that's my axis of symmetry. So my axis of symmetry is x equals 2. How do I find the rest of my vertex? Because remember, your vertex, your axis of symmetry gives you the first part of your vertex. So how do I now find the rest of my vertex? Oh, see, you do remember stuff I tell you. You're right, you plug it back in. So we have y equals 2 squared minus 4 times 2. So that's going to give us 4 minus 8. And last time I checked, 4 minus 8 gave us negative 4. So negative 4 is the rest of my vertex. So now I'm going to go ahead and plot that point. So we got 2, negative 4. Now remember, if your a value is 1 or negative 1, once you find your vertex, you can just follow your pattern. So over 1, up 1, over 2, up 4. Hey, look, there's my y-intercept. We already plotted that. I've got crazy points going everywhere. Let's get rid of that one there. Okay, and then let's go up to 9. So there'll be 5, 6, 7, 8, 9. And, oh my goodness, my pen has a mind of its own tonight. And let's go over here, this one. Okay, and let's go ahead and graph it. Now, this one, keep in mind, if it is just less than, is my line going to be dotted or solid? Good, got it. Alright, now, to graph it, I want to make sure that I have a dotted line. Okay, now this said less than, so when I go ahead and shade this one, I am going to actually shade below my parabola, so anything that is below my parabola. Now I'm sure all of you are doing much better coloring than I am right now. Okay, so that would be everything less than. And again, this time you don't want to test 0, 0 because that happens to be one of your points on your line, and it would actually be false because you would get 0 is less than 0, and that's not true. So you want to pick a point that's either really inside your solution area or really outside your solution area. Okay, try not to pick any points that are right close to the line that you graph for your parabola. Alright, taking a look at this one here, we know that our y-intercept is what? It's in standard form. Y-intercept tells you your standard form. What's your y-intercept? Ooh, good, 5. So we got 0, 5. Alright, so I know that we got the point 0, 5. So 2, 4, 5. Alright, there's 1 point on there. And we have, ooh, an a value of negative 1. What does that tell us about our parabola? What direction does it open? Nice, opens down. Alright, so we have a parabola that opens down. I'm going to do a little review of completing the square here. So I'm going to have y equals, I'm going to take out a negative 1 from everything. So that's going to be x squared minus 4x minus 5. And I'm going to hang on to that negative 1 for a minute here. And I'm going to do completing the square inside my parentheses. So minus 4x plus something minus 5. Remember, I'm working on the same side of my equation here, so I have to subtract that same value. Okay, half of b squared. So half of negative 4 is, and then square that. Good, so we're going to put in 4 here. You're going to factor this part, and you're going to combine like terms with the negative 4 and the negative 5 there. So this is going to be y equals negative 1, and then we have x minus 2 squared minus 9. Now we're going to redistribute that negative. So you're going to get y equals negative x minus 2 squared plus 9. So now it's in vertex form, so now you go ahead and give me the vertex. Oh, you remembered to change your sign. Nice job. 2, 9. So we're going to go ahead and plot the point 2, 9. Now, that's your vertex, and your parabola opens down. So this time when I do and my a value is negative 1, so I can still do my little pattern. So we got over 1, down 1, over 2, down 4. Oh, hey, look, there's the y-intercept. We had already plotted that. Then we got over 3, down 9. So that would be 5, 6, 7, 8, 9. Oh, hey, look at that. We just found our roots. Okay, now, less than or equal to, that's going to tell you that it is a solid line. We can go ahead and graph that. A solid line. Now it's less than or equal to, so I'm going to shade inside my, I guess inside the parabola. Okay? And again, you can pick a point in there to test, but that's where it's going to look shaded. Alright, for number 4, we have negative 2x squared minus 4x plus 5. So I know that my y-intercept is what? Good. See, you guys are doing awesome with this. You remember all this information. It comes all back to you. Now, your a value is negative 2, so that tells you that it opens, nice, down. Now, can I use my little pattern on this one if my a value is negative 2? Right, you can't, okay? So I would suggest probably the easiest way to go about doing this one would be to go to your calculator and get a table of values. Okay, so go ahead and go to your calculator, open up a graphing page. So let's add a page. We're going to add some graphs in here. And we're going to type in... Now, your calculator will actually do the shading for you also. So if you delete the equal sign, notice all of your inequality symbols show up. So what you can do is you can actually put in your inequality. So let's do greater than... Now, the problem with doing your inequality is that it won't show you a table of values. So what we're going to do right now is we're going to stick back to our equal sign. Maybe. Okay. So we're going to stick with our equal sign for right now so we can get a table of values, and then we'll come back and I'll show you how you can shade on your calculator. So this was negative 2x squared minus 4x and plus 5. Okay, so that's what our parabola should look like. So I'm going to do my Control-T shortcut, go to my table, and now it's looking like we have a vertex value of negative 1, 7. And the reason that I found that is because I looked for the pattern of my repeating values here. Okay, so I am going to go ahead and these values right here, from negative 3 to 1, I'm going to go ahead and put those on my table, on my notes. Okay, so after you have your table all set up here, now you're going to go ahead and plot your points. So go ahead, finish filling out your table if you haven't done that, and then go ahead and plot your points, and then join me when you're ready. Okay, so we had, it said greater than, so it's going to go ahead and be a dotted line for your parabola. Okay, and now I'm going to go back to the calculator and show you how you can shade. So I still had that in there. Let's get rid of our table here. And I'm going to go back to where I entered my equation in. So I'm going to go back up here. Now I don't want to get rid of, I don't know if it's going to keep it or not, but we'll try it. Let's see here. So I'm going to get rid of that, and I'm going to change it to a greater than symbol. Okay, now notice it changed to Y. So now I'm going to hit enter, and hey, look at that, it shades it for you. So now you can double check on your calculator, make sure you're shading in the correct areas. Now if you'll notice, if I put my cursor over the actual parabola where I graphed it, it's dotted. If it was supposed to be solid, it would show up as a solid line. So that also helps you out also. Alright, so I know that I am shading outside above my graph here. So I'm shading all around here and all around over here. And I hope your coloring is much better than mine. Okay? Alright. Now, number 5, we're going to do 2 parabolas at once. So what I want you to do for number 5 is I want you to go ahead and graph each one separately Don't shade them yet. Just graph each one separately. And what I want you to do is make sure you pay attention. These are both going to be dotted when you graph them. So go ahead, graph them both. When you're done graphing them, go ahead and join me. Alright, how to do graphing. Okay, so now let's talk about the shading. For the first one, oh, hang on, I didn't label my second one. This one should be y is less than 1/4 x squared minus x plus 3. So it's important that if you have two graphs on one, that you want to make sure you label them both. Okay, if it's just one, I'm not quite a stickler for labeling, but if you have two graphs or more on your axes, you better make sure that you have them labeled. Alright, so this one up here we have in red, the y is greater than or equal to, so if I shaded that, everything would be shaded inside my parabola. So I would have everything shaded inside here. And then if I shaded for y is less than, I would have everything that's shaded below. So there's two different ways you can do this. You can cover the entire shaded region, or what you can do is you can just shade the solution area. And in this case, your solution area would be right this little teeny tiny space where the two of them come together. Okay, so there's two different ways that you can do it, and then you would label it with an S. So sometimes there's a really large solution area, sometimes in this case there's a really small solution area. If I had to pick a point that was in that solution area, about the closest one I could get would be 2, 1. So a solution for both of them would be the point 2, 1. Okay, that lies in the solution area of both of them. Okay, the other option is that you can go ahead and shade everything. So like this would be shaded for the first one. And then if I wanted to shade the second one, I would shade down here. But again, where they overlap is your solution, and you want to make sure you label that with an S. Okay, for our last one here, what I'm going to do is I'm going to take what looks like one really big complicated quadratic inequality, and I'm going to split it up for you to help you out. So the first thing I'm going to do is I'm going to split this up into y is greater than or equal to x squared minus 4x plus 3. And then the other one is y is less than negative x squared plus 6. Okay, so I took what looked like a complicated quadratic inequality and I split it up into two. So what I want you to do now is I want you to go ahead, graph them, shade them, find me your solution area, and give me 1 point that's in your solution set. So 1 point that's going to be in the shaded area where they overlap. Okay, so if you'll notice, I have my two quadratics graphed, shaded. Keep in mind which one's dotted, which one's solid. And my solution area is in this little sliver in the middle between the two. Now, if you were doing this on your test, and you went ahead and you graphed and you shaded, you labeled your solution area, and Mrs. Croft comes along and takes a point off. What did I forget to do on my graph, folks? That's right, I forgot to label them. Alright, so this is going to be, this one here is my y is less than negative x squared plus 6. And this one up here happens to be y is greater than or equal to x squared minus 4x plus 3. Please don't forget to label, folks. Alright, that's it. You're done with your videos for this unit. And I got a little secret to tell you. There's no videos for the next unit, because it's short and sweet. So we're going to go back to doing notes in class. But I am going to try and do some classwork together, because I do like seeing you guys work together in class. Alright? Alright, I'll see you in class. Have a good one.